Hey y'all, Miss Brown here. Haven't done a video in a hot minute, y'all. Okay, so here is what y'all are gonna be working on Tuesday when you're working asynchronously from home. So this all about forces PowerPoint or slideshow. You're gonna fill it in and you're gonna just submit it as a Google assignment. So all about forces, you're gonna read this info and then you're gonna answer these two questions. What is a force, pardon me, and what unit is it measured in? And how can force affect how an object moves? Y'all have hiccups now. Then you're going to read these force facts and you are going to rephrase the four force facts. So, for example, a force is measured in a metric unit called newtons. You need to say that a different way, switch around the words, rephrase it, and type the first fact here. A force acts in a particular direction, rephrase that here. A force acts for a certain amount of time, rephrase that here. And a force usually cannot be seen, but its effects can definitely be seen. So you'll rephrase that there. Number 3, you're going to read this info and you're going to tell me what are two things that determines what happens to an object if a force acts on it. So it says what happens to an object when a force acts on it, and it has the two things here. So rephrase them. And then tell me what is a net force, which can be found right here. Okay, slide 4, you're going to read about balanced forces, and you're going to tell me what a balanced force is and how do balanced forces not affect motion. So if the forces are balanced, how come that makes an object stay still? Then number 5, you're going to read about unbalanced forces, and you're going to tell me how do unbalanced forces affect motion, and then give me an example of an unbalanced force here and a balanced force here. Okay, number 6, you are going to read this info about a vector and you're going to tell me what a vector is and what a newton is. So number 7, you're going to read this info about calculating vectors for net force for opposite forces, and you're going to answer this question. And then you're going to look at forces in the same direction and how do you calculate net force, and you're going to answer that there. Then you're going to complete the Venn diagram. I'm going to add this now. At least 3 for each bubble and 2 for the center, which is what is the same or similar. You're going to do the double bubble here. You can add text boxes and you can insert the text boxes and add your 3, 3, and then 2 things that are similar. I'll actually put another text box here for y'all. Oh, and then I'll put a text box here. And then you got spots. Okay, slide 10, you are going to give me an example of a push and an example of a pull, and then I want you to insert 2 pictures, one picture for your push example, one picture for your pull example. Okay, and then for this one, y'all, directions for the next 3 slides. So for each picture, you're going to draw arrows onto the picture to tell me about the forces acting on it. The bigger the force, the thicker the arrow, and the direction of the arrow shows the direction the force is going. So for instance, we have 2 arrows here. Let me annotate right here. So this arrow is darker and bigger because this force is the force that's winning out. They're going back a little, but then they're pushing with a lot of force forward in order to be able to bowl. So then right here, you're also number 2, be sure to show the correct size arrow since this force is bigger. Notice how that black arrow is thicker than this arrow up here. And then identify the forces as a push or pull. So right here, you're going to tell me whether it's a push or pull. And then you are going to determine whether the force is balanced or unbalanced. You're going to say whether it's balanced or unbalanced. And then this is the key part, y'all, the explain. So why is it balanced or unbalanced? So y'all are going to do the same thing. Oh, I don't want to end recording. I just want to stop. I just want to stop the pan. I'll just leave it. I think it's fine. Now, y'all, I can't figure out how to undo. Back. There we go. So right here, you're going to do the same thing with these 2 4 examples. So this one is a softball player hitting a softball. This one is a rocket. Number 3 is a parachute, so a skydiver falling out of a parachute. And then this one's a cute little bird sitting on a branch. Okay, for 14, you are going to look at this picture, 1,000 newtons and 1,000 newtons, and you're going to use the picture above to answer the questions below. Circle the best answer. So you are going to either, the forces above are showing pushing, or are they showing pulling forces? And you'll leave the circle wherever it may be for the correct answer. So I already did the circles for you, so you just move them to either circle the first word, pushing or pulling, or working together or opposite forces, or equal or not equal. And then number 15, same idea. You're going to look at this picture, 200 newtons to the left and 100 newtons to the right. And you're going to read each statement. The forces shown above are pushing, pulling, and same thing. You're either going to put pushing or you're going to put pulling, and then you're going to do the same thing for the other questions. Now, here's where we get into it. So you're going to fill in the chart on the right here, with the information found in the figure on the left. Remember, each square, graph square, represents 1 Newton. So we did the first one for you right here. So you're going to take a look at this vector, and you're going to see that it goes 1, 2, 3, 4 Newtons. So I'm going to put that vector 1 goes 4 Newtons. And which way is it moving? It's moving to the right. So I add that to the right. And y'all, I have this set up as, let me clear. I should have just done clear selection. There we go. I have it set up so that it is a table that you can type right into, so you don't have to do text boxes. So you're going to do the same thing with vector 2, 3, 4, 5, 6, 7, 8, 9, and 10. And it goes all the way down, hangs off a little. Okay, so then now we're moving on. So it says draw the specified vector below on the graph paper on the next slide. So you are going to draw these 4 vectors, 1, 2, 3, 4. And you're going to draw them on the next slide. So I did the first as an example for you. Remember, 1 square is 1 Newton. So all the vectors will be drawn on the same graph. I did an example. So this one's my example. If you have 6 Newton force up, what is that going to look like? So I'm going to go here. Anywhere you want, just kind of spread them out. So I started right here at the bottom. And I like to have like a circle, but it's hard to do with the drawing tools. So you're going to go 1, 2, 3, 4, 5, 6, and it's 6 in the up direction. Go back. It's 6 in the up direction, so that's why I did 6 in the up direction. So you'll do the same thing with these 1, 2, 3, 4. I forgot to show y'all how to draw the arrows, because you're going to need to know how to draw the arrows on this one. So you go right up here and you click the arrow tool, and then you just draw the arrow the way you want it. You can go up here, you can change the color, and then this is where you'll do that thickness. So if it's a big force, you're going to do it as a thicker arrow and as a longer arrow. And if it's a thinner force, you can do it as like a 1 or a 2. So my suggestion would be like 1, 2, 3 for the shorter or less force arrows, magnitude, which is direction and force, and maybe these bigger ones like 4, 8 for the bigger ones. And you can draw longer or shorter arrows. So keep that in mind, because you're going to need to know how to do that for this one too. So same thing, I have arrow. Let's say I want to start here and I'm going to the right, 1, 2, 3, 4. I would do it just like that. And then I would do it in a different color just to kind of show me. You don't need to worry about the size of the arrows here, because we're just drawing the vectors, as opposed to these ones, the thickness or thinness of the arrow does matter. Okay, y'all, almost there. So the 6 sets of vectors are shown on the next slide right here. So what you have to do is you have to figure out what the net force of the vectors are. And remember, you figured out how to do that right up here by looking at whether they are balanced or unbalanced, but not only that, whether they are in the same direction, right here, opposite directions, or whether they're in the same direction. So you are going to use a bright arrow to draw the net force next to the vector. Remember, the net force is the sum of the arrows in the same direction, or the difference of the arrows in the opposite direction. And then you're going to start at the dot, and then number 1 has been done for you. So if you look at slide 20, I have 4 Newtons here, and then I have 10 boxes. So I put 4 plus 10 equals 14. So what I did was right below it, or right next to it, you're going to draw that net force vector. So since both of these are in the same direction, you are going to add them together, draw it, 14. Same thing. I would go up here, y'all, and I would pick different, colors for each one. So if I'm doing this one, maybe I would draw it somewhere right around here. If I were doing 2, I would draw it right around there. Maybe 3 I could put there or below it. Maybe 5 I could put here, and then 4 I can put next to it. You're just going to try to put it like as close to that one as you can. And if you want to do what I did with the text boxes to kind of check your answers, that's a great idea. Just be aware that, for example, number 6, they're moving in opposite directions. So you need to look back at slide 6 to figure out what does that look like if they're moving in opposite directions. So slide 7. And if they're moving in the same direction, slide 8. So just be aware, for example, number 6 is in opposite directions versus number 2 are moving in the same direction. Okay, y'all, so you're going to use the information from the vectors on the previous slide, and you were going to fill out the table on the next slide, which is pretty much exactly what you did here, except that was just one vector. So now what you're going to do is you're going to show your work for what I did up here on this slide. So notice how I had 4 plus 10 equals 14. So I went down here and I put there's 2 total forces because there's 1, 2. And then I put that it was 4 newtons, you need units, no naked numbers, plus 10 newtons equals 14 newtons. Since it's moving to the right, because the arrows are going to the right, and it's going to be an unbalanced force, y'all, because it creates motion. If you have 2 to the right, 2 to the left, and you stay still, then that would be balanced. If you have 2 to the right, 4 to the left, that means you're going to be 2 to the left, which means it's going to be an unbalanced force. And I think that's it, y'all. That was the last slide. So once you do that, you're going to submit it in Canvas as a Google assignment. Okay, love y'all. You fill my buckets each and every day. Hope you're having fun at your asynchronous day at home. You lucky ducks. Lucky ducks. Love y'all. Bye.